Welcome. So today I'm going to talk to you about what is computer hardware. Okay, so before you can understand what computer hardware is, you need to understand what it isn't. And so there's two big components of a software system. One is software, one is hardware. Basically, the hardware is anything that you can touch. It's the physical components of the PC. So if you can reach out and touch it, then that's hardware. And the software is the programs that run on the hardware. So things where you press the screen and it opens up an app or a program. That's software. Okay, so let's get a little bit technical. What you see on the screen now is called the 5-box model. So the 5-box model has effectively got 5 boxes in it, clues in the name. And so within that, we've got 5 separate components that make up the standard kind of computer hardware. And most things fit into this classification. So starting off, we've got the input devices, things like mice and keyboards and maybe even microphones. They send commands sent by the user or data entered by the user over to the central processing unit. So the central processing unit, we'll come on to in a little bit, but it's basically a massive brain in the middle of the computer, a load of circuits that take inputs and they turn them into information that's either displayed on the screen or given to you through the speakers or maybe even printed out. And so those collection of devices are known as the output devices. Now, if you had a system which just took inputs, processed it, and gave an output, that's basically any kind of machine. So a calculator does that, and really that doesn't really differentiate itself from a computer. And so the two other key components that all computers have are secondary storage and main memory. Now, the precise definitions of the two we're going to come on to later as well, but to summate, secondary storage is long-term storage. It's the place where you store the things that you want to keep for a long period of time. Your main memory is your working memory. It's all the kind of ones and noughts that you need to carry out the task in hand. And so the secondary storage is going to store programs and files, whereas the main memory contains instructions and data. So if you kind of conceptualize in your head, you have a program on the computer, you double click on that. The moment that you double click on that program, the instructions from within that program are moved from the secondary storage into main memory. So I said we'd come back to the CPU, and we'll do that now. So the CPU, also known as a central processing unit, or more often than not just the processor, is the brain inside the middle of the computer. It works using binary machine code instructions, so it works using ones and noughts. So the pins on the one side of it receive a set of electrical signals as ones and noughts, it processes them, and it puts some other electrical signals out on the other side of it. It takes the programs that have been loaded into RAM from the secondary memory and carries out their instructions. It fetches one instruction at a time, decodes it, and executes it. That cycle is called the fetch, decode, execute cycle, and it carries out that cycle billions of times every second. It has some onboard memory, and these memory locations are known as registers. Okay, so the 5-box model is kind of a bit of a weak level of understanding. It's what's pitched kind of before GCSE, and so to get into a little bit more detail, we need to introduce a set of wires known as the system bus. So the system bus is given the name because it connects the whole system together. The word bus, you shouldn't really think of a vehicle. Think of I think it might be Latin or Greek term omnibus, which means for all. So it's a set of wires that are accessed by all devices in some form. And so again, you can see that you've got your 5 key groups of devices. You've got your secondary storage, your main memory, your input devices, your output devices, and also your central processing unit. Notice the arrows within here imply the direction that data is traveling on and off the buses. So you can, and also that most devices have another processor between them and the main processor. This is known as a controller. So we'll go through them one at a time. So we'll start with the input devices. I haven't really expanded these in any way from the previous slide, but as I said, they contain things like the keyboard and the mouse, and they have a controller. And notice that the arrow goes from the input devices to the system bus, because input devices by their very nature send data into the system, so they input data to the system. Moving along, we've got the disk controllers and the hard disk. All the arrows here are bidirectional, so the processor can save data onto the hard disks and the USB drives, for example, and also it can read data from them, and therefore it needs to go in two directions. In addition to that, we've got this other processor called the disk controller, which can help integrate the two systems together. The output devices, we've got a range of different output devices here. We've got sound, printing and display devices. Each of those have got their own controller, so you will have some form of controller which for dealing with sound, which is generally known as a sound card. Your graphics card also does some onboard processing, and that's used to connect your computer to the monitor or the screen. And then finally the printing devices. Often these days these are actually connected via a wireless signal, but I've supposed that there's some controller between them and the system bus. Moving up, we've got main memory. Now, in the previous demonstration, main memory, I just said, that's the working memory of the computer. However, there's two kind of key parts, which we'll look at the next slide. We've got the random access memory. That's your temporary working memory of the computer. And then you've got these things called ROM chips. That means read-only memory chips. And they contain short sequences of instructions that are used for things like storing firmware, which is the actual instructions to control the hardware, that's hard-coded onto the actual hardware device, and also things like the instructions for booting the computer, which need to remain on the chips while the computer's turned off, and that's how it's effectively different to the RAM. And then finally, for some reason I placed it in the bottom corner, but I suppose in this model it could be placed anywhere, we've got the central processing unit, which I've just described. Alright, so last slide. So one of the key things to get your head around is the fact that we've got two kind of areas where we store data. We've got memory and storage. So when we're talking about memory, we're thinking of it storing instructions and data. So we're not thinking of it as whole files necessarily. We're thinking it little snippets of instructions, little snippets of data. So there's two kinds. There's RAM, or random access memory, which is sometimes referred to as main memory or primary storage or primary access store. This is the working memory of the computer. When you double click on a file, the file and the program required to open that file are transferred from the secondary storage, so from the hard drive, into the RAM. It's the working memory of the computer, as I said, and it's volatile. What volatile means is when the electricity within the computer fails, so does the data that's stored in the RAM. And you may have experienced this if you were in a power cut and all of a sudden all of the electricity went, and therefore so did your data, because you didn't save it in time. That's why we lose things before we save them. And then the other kind of memory that you find within sort of the primary storage is ROM. These are read-only memory chips. They store the firmware and also the boot up instructions for the computer. Now, it would be pretty silly to have your boot up instructions lose memory when the computer's switched off, because then when you switch the computer back on again, it wouldn't be able to boot because the instructions would have disappeared, and therefore your ROM chips need to be non-volatile. The thing about memory is it is directly connected to the CPU. So when you looked at the previous slide, most of the devices had some form of controller between them and between the system bus and them as a device, whereas the main memory is not. It's directly addressable by the CPU. So the CPU can, without saying, can I speak to the controller, and then can I speak to this specific bit of storage, it can just go, look, I want to go to this position within this storage. So it's directly addressable, directly connected to the CPU. Secondary storage is the long-term storage of the computer. It's where your programs and your operating system and all your files live when your computer turns off. Because they need to live there when the computer's turned off, the data must remain there when there's no electricity, and therefore we use the term it's non-volatile, meaning it will be stored even if there's no electricity there. Stores your program and files. It's also got a thing called a file allocation table, which allows the computer to store it in a more systemic manner. So you'll be familiar with the fact that you have folders and drives, and so that directory structure is built into the storage devices and provided by your operating system. Types of secondary storage devices include hard disk drives, USB sticks, CD-ROMs, DVDs, solid-state devices now. And the other bit to remember is all of these need to be accessed via another smaller processing unit called the disk controller. So, from your input devices to your output devices, from your secondary storage to your main memory. I've hopefully given you a whistle-stop tour of how hardware works inside of a computer and what hardware is. Thank you.